Hey guys, how are you doing? This is the sixth video of the Sitemap crawler project series. Now, I had taken quite a bit of a break from this project, and that's because I got a lot of urgent requirements from people on YouTube saying that they want to learn authentication, they want to learn CRUD, or they want to learn about Postgres or Redis or MongoDB or Gin and Fiber. So I just got lost in all of those requests, and I tried to, fulfill those requests, the learning requests that people had from me, because some people were working on like current projects at that particular point of time. They needed my help, so I created videos around that. And now that I have time, my calendar has cleared up. I've come back to the series, and I want to finish many more old series because I feel I've created quite a lot of content on my YouTube channel, which covers a lot of the basics, a lot of stuff for advanced people, also a lot of stuff for intermediate people, also like intermediate learners, advanced learners also. So now I feel like I have the time to focus back on this series, and in a couple of videos we'll finish this also, because there isn't much left to do out here. Now I want to quickly repeat what we're trying to do here. We want to go to a website, and basically we'll put the sitemap URL link here of that website. So usually websites have almost all websites have a URL, especially the ones that want to compete and want to be really good at SEO, right? So they have a sitemap URL, and then that sitemap URL is what we're going to put here. So our program is going to go to the sitemap URL and is going to crawl every single link on that sitemap. So sitemap is basically a page which has all the links to your website, all the links of all the pages in your website. Our program is just going to click on every single link and is going to scrape that entire page. Okay. And just to verify, just to see that everything works. So that's why it's a sitemap crawler. So right now we're just going to scrape it. We're not going to do anything with that information, but that's where I'm going to leave this program off. But you could take this program and build and take this and do it, use this functionality for any other website that you want to crawl. And using the sitemap, you can crawl every single page of that website and actually do something that you want with the information. For example, you want to harvest other people's email IDs from, let's say, websites, or you want to get phone numbers, or you want to get some information like news information, you want to organize that. This is the way to go. You get to the sitemap, use crawl all the links, and you scrape all the pages. So we're going to crawl through the links, we're going to scrape all the pages, but we're not going to do anything with the information, right? So you'll be doing something with the information later on if you want to. Okay. So I hope that makes sense. Now, when I say doing something with the information, I mean that you can store it, you can mine it, you can refine it, you can use machine learning to train on that data. You can do a lot of stuff, and I can cover that in one of the future videos, but that's not the scope of this series. Here I'm just teaching you how to crawl and how to scrape, right? So now coming back, I want to start again from func main. And so P is something called as a default parser, right? Now default parser is an empty parser right now. It's an empty struct. And parser, just parser, is an interface that helps you to talk to this function very easily, get SEO data. Okay. Now, coming back here to a func main, what I want to do is I want to actually put in the name of the website that we'll be scraping. Now, there's a very famous website when it comes to SEO. There's a very famous website called QuickSprout. It's owned by this person called Neil Patel. He's the biggest person in SEO. And his website is the one that we'll be scraping. All right, so let's put in his website. It's quicksprout.com. You can check it out, /sitemap.xml. So usually if anybody wants to do really well with SEO, your sitemap.xml needs to be right there with your domain. It can't be with your subdomain, or it can't be like, /about/sitemap.xml. It can't be like that. It has to be on your main domain name. So it's quicksprout.com/sitemap.xml. So I'm assuming, since he's the guru of SEO, that definitely he would have kept a sitemap.xml like this, right? Now there are two more things that I'm passing here, P and 10, which I'll talk about really soon. Now, when you look at this function, scrape sitemap, you can see an obvious default here that I made in the long time back when I made the fifth or the fourth video. So I need to fix that. It needs to be capital S, because that's what I'm calling here, scrape sitemap. Okay, and you notice here that's only taking a URL for now, but we want to take something else also. We want to take those two other values as well. So what I want to do is I want to say it takes a parser And parser, by the way, is the parser that we talked about, that we created here on top. That's the parser is taking, right? So parser called P, which helps us to talk to this get SEO data function later on. All right. So it takes a parser of type parser, which is an interface. And when we say 10, we are basically defining the concurrency. So that's what we're also taking. Now, all this function returns is the SEO data. SEO data is the struct that we have already defined, right? So I'm just going over all of this. I know you might feel like you already know all of this, but I'm just going over it so that you don't miss out any information, because it's been quite some time since you must have done the 5th video to this 6th video now. So SEO data was that struct, and we want the data to be structured in this way, right? The URL, title, h1, meta description of all the pages that exist on our website. Now, like I said, even though we are scraping the data, we're getting it in this kind of a struct format, but we're not doing anything on the data on the pages. But you could, if you wanted to use this program, you could actually deploy this program because it has concurrency. It's very fast. It's super efficient code that we are writing right now. You could use it to actually scrape a huge website and get all of the data, scrape the data, and structure it like this, like I showed you. I showed like 5-6 fields, but you could have many more fields. You could structure it, and you can actually do something with the data, like get phone numbers and extract email addresses and all that stuff. All right, just an idea, just a business idea that I'm giving you. By the way, I do this for my product, Dominate.ai. This is what I do. I have millions of scrapers out there on the internet, scraping millions of websites, and they're getting all this information for me, like emails and phone numbers, and that's what I kind of organize and structurize, and I provide and clean all the data, and I provide that on my product, Dominate.ai. I provide that to salespeople. They subscribe to my platform, and they get access to this kind of data. All right, so that it makes it easy for them to sell. Anyhow, so I just gave you a very awesome business idea. Anyhow, now going back. So that was our sitemap, scrape sitemap function. Now you see that in this extract sitemap URLs function, right, which basically extracts all the URLs from the sitemap, you're just passing the URL of this link. But in your scrape URLs function, you want to pass something else. You want to say, you want to pass the parser, and you want to pass the concurrency. Okay. Now that means that we have to go back to our scrape URLs function and work on it. So till now we haven't worked anything on our scrape URLs function, but this is an important function. So now you just saw that it takes URLs, sorry, not here, but within these brackets, it will take URLs, all the URLs, not URSL, or URLs, and which is basically a slice of strings. And you just saw that it takes parser, and you just saw that it takes concurrency. Now just make sure it's consistent with your other program. Now what's happening here is that you get all the URLs, right, in your variable called results in this function, scrape sitemap, and you call scrape URLs function, and you pass all the results that you just got from this function. You pass the parser that we had here, and you pass the concurrency, which is 10. And now going back to your scrape URLs function, it has to return something, right? This function returns something. In our case, this function returns SEO data. This bracket needs to close here, the square brackets, to indicate that this is a slice of SEO data. SEO data is our own struct that we have defined out here, SEO data. So struct is basically a collection of different data types that you can create inside Golang. So it's our own defined struct. So now let me go back to my function scrape URLs. Okay, here the way I want to start is I want to create a variable called tokens. And it's nothing but a channel with a set number of concurrency, like 10. Concurrency of 10 is a channel. Then I define a variable called n, it's an integer, and I define a work list of different links. It's again a channel of slice strings. And because we want the SEO data to be structured, we want to return a structured data from here. Structure in the sense, all the data that we'll get right now from scraping all those URLs, we want to structure it like this. And to be able to do that, we have to have a variable that we return from this function, right? The variable that we'll return from this function will be called results. And it's and right now, like to begin with, when we're initializing it or creating an instance of it or initializing it right now, it has to be empty. It has to be a slice which is currently empty, right? There's nothing in it for now. And that's how we'll fill it up because it's empty in the beginning. Now you start a go routine, go func. And for when n is greater than 0, you basically start with a list of all the URLs, and then you have to just go over them one by one till it becomes 0. And you're getting access to the list from this channel. Okay. Now, the reason we use channels and routines and all of that is because you don't want this to happen linearly. You don't want the URLs to be scraped linearly because as in there's this list of URLs that are being passed here, and all of those URLs indicate a page, right? Because you click on a URL, you go to a page, and all of these pages, there could be hundreds of pages, right? On because his website is quite big, quicksprout.com. It's quite a big website. It'll have hundreds of links, and hundreds of these pages need to be scraped simultaneously. Like need to be scraped, period, right? But you can't wait for like let's say if you were using JavaScript or some stupid language like that, right? We would have had to wait for like you can't just do all of those concurrently. You can't just do all of this together simultaneously, right? With JavaScript, you would have to wait for one page to get scraped, then you have to scrape the other page. But with Golang, you can scrape all of them together at the same time, and this is why we use channels and go routines and all of that, because we are basically creating a channel where all of the scraping can happen simultaneously. Now, I use a lot of JavaScript. I use a lot of Node.js in my own products, and I call it stupid because I've had a lot of problems with it. I have problems debugging JavaScript a lot, but I still learn. I still, I'm pretty good at JavaScript. I will be teaching JavaScript for some tutorials like React, because that's the best. That's basically the best front end framework, right? React and Next.js and Redux and hooks and all of that is the best for front end. But for back end, even though I use a lot of Node.js, I somehow like Golang a lot more because there's so much concurrency, and its debugging is so much easier, right? Anyhow, so what you want to do is you want to range over all the URLs, the list that you just got, and if the URL is not empty, that's when you want to do something, right? If it's empty, then you don't want to do anything. If it's not empty, then you want to increment n, and you'll have a go func. Channel struct. And so what's happening right now is you have the URL, like every single URL is coming to this go routine, and it's going to request every single like data from that every single URL. So it's going to say requesting that URL, requesting URL, and you will say %s, because we want to know, like as somebody who's going to run this program, we want to know which URL. Sometimes we want to know which URL took too much time, because if there's a really big page with a lot of images and a lot of videos, and Golang is not able to come back, like that process is not able to come back from that page, that means that page is really big. We can avoid it later on, right? So so that's the best part with Golang, that all of these processes happening simultaneously, concurrently, and you don't go routine doesn't have to wait for another go routine to finish, right? So they can all happen independently. Otherwise, if one page was really big, the complete program would have stopped just to wait for that one page to get scraped. I hope that's making sense. And I'm going to capture something in this variable called result, and that's basically going to be my scrape page. So you get each of these URLs, and all that this routine is doing is calling this function called scrape page, which is this function, right? It scrapes every single page. So scrape page, and you say tokens and the parser. And you can also check for errors here itself. So if error is not equal to nil, you'll say log.printf and countered error on which URL. So you can also say on this URL I encountered error. That does not affect our entire program, right? So only in that URL you have an error. So imagine how amazing that is, right? Your entire program does not have to stop because you found an error in one particular page. And this is why Google uses Golang as the primary language these days. I don't know if you know what's happening inside Google these days, but from what I know, from what I've heard, from all the people that I know, they use Golang very heavily in scraping and crawling all these different websites. Earlier, they used to use a lot of Python, but now they've started using more and more of Golang. It's very, very resource efficient language, right? You get so much concurrency. Then at the end, you're sending this to the work list. And that's it. So you pass all the URLs here, the complete list of URLs, and you take all the URLs one by one. One by one, you'll take the URL in this Go function. All of this happening simultaneously. Remember that in different Go routines. All of that pushing everything into one single Go channel, and all of the Go routines are calling this function scrape page, and you're getting the data from every single of those pages. So I'll just repeat again. You have a sitemap. Sitemap has hundreds of links, URLs of the entire website. That's what is the sitemap. We want to go across all the URLs. We want to take that list. So we'll go across all the URLs here, right? And you want to take that URL list, and you're going to pass that URL list here, and that results to the scrape URLs function, which is basically going to create multiple routines with one single channel called work list, and all of the routines are basically going to call this function called scrape page. Scrape page function just takes whatever data it finds on that website, on that page, that single page, and basically gives us a structured data in terms of the struct that we have defined. And that's the complete flow till now. That's what's happening till now. Okay. So I hope that makes sense. And that's all that I want to cover in this video, at least. In the next video, we can start working on our crawl page function, which I don't think there's much to be done here, done there anyways. So thank you for watching, and I'll see you in the next video. Do subscribe to this channel if you haven't already, because you'll get access to such awesome content all the time. Okay. And thank you. See you.